good deal. Let's go. Okay, so vertical asymptote. Somebody tell me what they think? -1. 3. All right. So let's look at what we're supposed to be looking at. For vertical asymptote, you look at y being negative infinity and positive infinity around it. So if it's -1, then on this side and on this side, those two should not be approaching the same number. They should both be like getting really, really big, one of them, and the other one being really, really small. Is that happening? Not on that one, no. But we're going to come back to that one. The next one was this number. So we look on either side. -99,998. I'd say that's really small. That's a negative, by the way. And this one's really big, so yeah. X = 3 is a great vertical asymptote. What about horizontal asymptote?
2.
Okay. Anybody else put something else? Okay, so if it's 2, then what you do is you look at the ends of the x's, negative infinity, positive infinity, and you see what these two are approaching. They are indeed both approaching, getting closer and closer to 2. And then the whole must be the other undefined. So the whole, this is -0.499 on this side, and this one's -0.501. So it's getting closer and closer to what? -0.5. So the whole would be -1, -0.5. So these are the 3 things that you need to know to figure out the domain and the range. But for this problem, it's just the domain. So negative infinity to the vertical asymptote and to the whole, the x coordinate of the whole. So to -1, then -1 to 3, that's the vertical asymptote, and then from 3 to infinity. And so knowing the hole in the graph and the vertical asymptote help. Okay, good. B, does either factor in the denominator also exist in the numerator? Okay. Yes. How do we know yes? Yes. When you have the exact same factor in the top and the bottom, they cancel, creating a whole or point discontinuity. Absolutely right. So, yes, because there is a hole at, -1, -0.5. That'll work. So, what is that factor? There you go. So the factor is what would give me the x coordinate of the whole when I set it equal to 0. It didn't really ask me for the factor, but it'd be a good idea to put it in anyway. C, does either factor of the denominator not exist in the numerator? Yes. What is it?
X = 3.
Yeah. Let's see, I'm going to write it this way. There is a vertical asymptote at x = 3. So, the factor is what?
X - 3.
Very good. So where's the horizontal asymptote? We already found that. It was at g of x equals 2. So it says based on end behavior, that was as x approaches negative infinity, g of x, it's supposed to be a capital, approaches 2, and as x approaches infinity, g of x also approaches 2. So y equals 2 is a horizontal asymptote. So this last one, we would need to read the directions a little bit more. The equation of g of x is such that the denominator of the function is the quadratic expression 2x squared minus 4x minus 6. So that's just saying, we know we have something on top and our something on bottom. It's 2x squared minus 4x minus 6. And the question says, what must be the leading coefficient of the numerator of the equation of g of x have to be? Explain your reasoning. Well, our leading coefficients horizontal asymptotes, if it's not just equal to 0, let me ask this question a different way. What are our possibilities with the heavy thing, with horizontal asymptotes? Yeah, we have top heavy, which means there's no horizontal asymptote at all. It's a slant asymptote. We have same heavy, which means it's the leading coefficients, it's the ratio of those. Or bottom heavy, which means it's y equals 0. Well, I know my horizontal asymptote is not 0. It's 2. It says so right there. I know it's not none because, again, it's 2. It says so right there. So what kind of heavy do the exponents have to be? Same heavy. So I know it's going to be, both of them are x squared, some number over 2, because that was my leading coefficient on the bottom. And it's got to equal 2, because that's my horizontal asymptote. So how would I solve that? How do I solve for my top number? Multiply both sides by 2. A is 4. So the leading coefficient of the numerator has to be 4. So then when I divide it by 2, I get the horizontal asymptote, which was 2. And this is good enough for my reasoning. Okay, we have a free response question that we can do together. Okay, so we have two rational functions here. 2 over x minus 3 and x minus 2 over x squared minus 9. A says at what value or values of x will the graphs of f of x and g of x have discontinuities? Explain your reasoning. All right. Discontinuities, remember, occur when it's undefined. Undefined happens when you have 0 in the bottom of the fraction. So if I factor everything, I have f of x. Now it doesn't factor. And g of x This one does. Top doesn't, but what's the bottom factor into?
X minus 3 plus 3.
Good. So, discontinuities occur where? Yes, when the bottom is equal to 0. So when x minus 3 equals 0, which is when? X equals 3. Same one here. Or when x plus 3 equals 0. So discontinuities occur at x equals 3 and x equals negative 3. And that work is our reasoning. You could have also written as x equals plus or minus 3. That would have been fine. So it asks us for discontinuities. That's when there's a hole in the graph or a vertical asymptote, either one.